Okay, well, welcome to special types of random variables. So we've talked about discrete random variables, continuous random variables, transforming random variables, and even combining random variables. Now we're going to take a look at two special types of discrete random variables, and this will actually wrap up our study of Unit 4 for AP Statistics. Now, we're going to talk about the binomial distribution, and this might seem completely new to you. In Algebra 2, sometimes you all cover combinations and permutations, but that's not written in everyone's curriculum. So it is weird. It feels really foreign at first, but once we understand our conditions, we're able to check them out, and we're able to verify our setting here. So when the same chance process is repeated several times, we are often interested in whether a particular outcome does or does not happen on each repetition. Some random variables count the number of times the outcome of interest occurs in a fixed number of repetitions. This is what we call the binomial random variable. So this is a binomial setting or a binomial, so I'm going to put both, binomial setting or a binomial random variable here. Now, there are certain conditions that were just described in the situation here. So we're looking as to whether a particular outcome does or does not happen on each repetition. So our first condition is that in a binomial setting, the variables must be binary, meaning that it either does or does not happen, and most oftentimes we call this a success or a failure. Now, a success doesn't always mean a good thing. You could have a binomial random variable with, who knows, like student loans or debt or something negative. So just because it says success, or death rate even, just because it says success does not mean it's a good thing. It just means that the event happens, what we call a success. The next condition is that knowing the results of one trial must not tell us anything about the results of another trial. Well, we've talked about this condition again and again, and this is what we call independent. One variable has no influence over the other, so this is an independent condition. The next one is that the number of trials n of the chance process must be fixed in advance, so we call this n fixed trials. A really weird way to say it, but basically you have to have a fixed number. And then lastly, there's the same probability of success on each trial, so that's our success p. So when you are in a binomial setting, or when you think you're in a binomial setting, you are checking for bins. You're checking for binary outcomes, independent outcomes, and fixed number of trials, and then a fixed probability of success here. So these are the four conditions we look for in a binomial setting. And then, if we verify these four conditions and they are met, we will say, since the conditions are met, we have the following. So back to our normal distribution days, we're going to let x be distributed binomial, have a binomial distribution with parameters n and p, where n is the number of fixed trials and p is the probability of success. So again, this just reads as x is a random variable that is distributed with the binomial distribution with n fixed trials and p fixed probability of success. So we have a few examples here of some situations, so determine whether or not the situations are binomial. Drawing a red card without replacement from a standard deck of cards, or shuffle a deck of cards, turn over the top card, put the card back in the deck, and shuffle again. Repeat this process 10 times. And I think I meant to put looking for a red card as well. Whoops. But essentially here, you are checking the bins condition. So you're checking, are they binary? Are they independent? Is there an n fixed amount of trials, and is there a fixed probability of success? So go ahead and take a look at those two for some binomial examples.